All right, so the reason I picked this is because the top is 0, and this is a very common mistake So you are going to take your antiderivative, so it is going to be 1/3 x cubed minus x. You are going from -2 to 0. So don't forget that you do plug in the top number first. So when I plug in a 0, that does give me 0. But I have to plug in the -2. So I'm going to say 1/3 times -8 minus -2. A lot of times people forget they have that 0 in front when they do all of this. So -8/3 plus 2 or plus 6/3 is -2/3, but I am subtracting a -2/3 there. So it is a positive 2/3. So the antiderivative sign is cosine, cosine is sine, but remember, antiderivative from sine to cosine negates it, right? So this starts out as a -2 sine, so when I take the antiderivative, it's going to be a positive 2 cosine. And I am going from -pi over 2 to from -pi rather to -pi over 2. So for this one, I am just going to plug it in 2 cosine of -pi over 2 minus 2 cosine of -pi. -pi over 2 is down. It doesn't really matter though because the cosine there is 0. So 2 times 0 is going to be 0. Minus 2, the cosine of -pi is -1. So you have minus a -2, which gives you 2 there. Remember I said you have to figure out where it equals 0. And in this case, we have 2. If I set this guy equal to 0, you factor it. And there are actually 2 places at x equals 0 and at x equals 2. And so then I'm going to go to my boundaries and say, do either of those fall in my boundaries? Well, they actually both do, okay? So I actually have to set up 3 different integrations here. I have to say, well, from -1 to my first one, I am going to do something with this x squared minus 2x. And then from 0 to my next one, I'm going to do something with this guy. And then the last one will be from that 2 to the end of it, 2 to 3. All right, so then I really need to figure out, do I get a positive or negative in here if I plug something in? So like for this first one, if I plug in like a -1/2, I get 1/4 plus something. So this is actually going to be positive, so I don't need to negate anything to ensure that my absolute value is positive. From here, from 0 to 2, let's say I plug in a 1. Well, 1 minus 2 gives me a negative here. It's absolute value. I have to force this guy to be positive. Anywhere from 0 to 2 is going to give me a negative number here. So I need to force it to be positive with a negative. So for this one, I'm actually going to put a negative in front of it because anytime I plug in from 0 to 2, I'll get a negative. I don't want a negative, it's absolute value. So I'm going to force the positive. And then in the next group, if you look over here, if I do anything from 2 to 3, I'm actually going to get a positive number here. So if I do like 5/2, I'm going to get a positive number here, so I don't have to negate this guy. Make sense? So you just have to figure out in that group, is it going to make my absolute value inside of it negative? If it does, do the opposite, negate it. And then you're just doing these intervals. Again, pay attention to your zeros here, because for this first interval, your 0 is on top. The second one, your 0 is on bottom. So all of them are going to look the same, 1/3 x cubed minus x squared from -1 to 0. This is just going to be negated. Negative 1/3 x cubed plus x squared from 0 to 2. And then 1/3 x cubed minus x squared from 2 to 3. And then just plug it in. So this one zeroes out, but remember you are subtracting there. So you do have negative 1/3 minus 1 for that one. So this is negative 4/3, but you're subtracting, so it's a positive. Here you're plugging in a 2, so you get negative 8/3 plus 4 or plus 12/3. So you get another 4/3 there. And then for this last one, and it's subtracting 0, so that's good. For this one, you get, what, 9 minus, oh, that's going to be 9. All right, so that's 0. Minus, and then we're plugging in a 2. So we get our 8/3 minus 4. So this is going to be, again, minus a negative 4/3. So this is going to be 4/3. So we get 12/3, which gives us 4. So if you read your instructions, find f of x, but it has my little derivative mark, right? So it's telling me to find the derivative of my antiderivative, which is really just what happens when you plug in your numbers. The problem is if you plug in a 5 here and then take the derivative, it's going to zero out. So you actually don't even have to worry about that number at the bottom, because when you take the derivative of a number, it's going to zero out. I really only have to worry about this top thing. What happens here is I end up plugging in that x squared, because if I take the antiderivative of that and then take the derivative, I'm going to end up with this function, right? But they want me to do it from one number to a function. So I really just have to worry about what happens when I plug that function in then, because antiderivative says plug it in and subtract, right? So I have to plug it in. So I'm going to say x squared in the first part, and then I actually have squared, plus 8 times x squared, that's my top function, plus 11, all right? And then that's all great, except I need to consider the fact, one, I'm going to obviously simplify x to the 4th plus 8x squared plus 11. But when I take a derivative, I have to consider the chain rule, right? And this x squared was within that when I went back and did my derivative. And so I actually have to multiply this whole guy by whatever the derivative of this would be. Well, the derivative of x squared is just 2x. So you're just basically taking your function, plugging in your top function, and multiplying it by the derivative of that top function.
So why?
Here's what happens. I would have done t cubed over 3 plus 4t squared plus 11t. Yes? Okay. And then it wants me to do it from -5 to x squared. Yes? So then I plug in x squared. I plug it in here, I get x to the 6 over 3 plus 4 x to the 4th plus 11x squared, right? That's what happens when I plug. Then I'm going to plug in a -5 and get some constant, right? This is going to be a constant, yes? Mm-hmm. And now they want the derivative of this guy. Now I'm going backwards the other direction, so I'm going to go back the other direction. Well, that's going to be multiplied by the 6, right? 6 over 3 gives me 3. Right? Subtract 1 to the 5th. Like, we're going back through the process, right? When that happens, you end up dropping off the other guy, and all you're doing is considering the fact that you had to multiply everything by this this derivative. So instead of going one way and then going the other, yes. So instead of doing that whole process, then going back the other direction, you realize if I take the antiderivative and then the derivative back, I end up where I started from. That's easy enough. My 5 is going to drop off because any constant is going to zero out when I take it back the derivative. But the x squared is now in it because I had to plug it in. So I plugged in my x squared, but when you take a derivative and there's a function inside a function, remember, that requires the chain rule, right? So anytime you had like sine of x squared and you took the derivative, you just did the cosine of x squared, but then you had to multiply. So plug in your top function because that's the only thing that's going to stay around, and then multiply by the derivative. And so you do want to simplify it. You do want to go back through this and distribute. So you would say like 2x to the 5th plus 16x cubed plus 22x, right? But that's what would happen if I took my derivative here, right? If I took my derivative, I would say 6 over 3. Well, that's a 2, and my new exponent is x to the 5th. 4 times 4, that's going to be 16, and my new is x cubed. 2 times 11, well, that's going to be 22, and that's going to be x. See how I got the same thing? And this constant that I would have plugged in is going to zero out.
Yes, ma'am.
Okay, so instead of going through the whole antiderivative, plug it in, derivative, just know you end up where you started from, and then you have to apply that chain rule concept, multiply by that derivative.
Thank you.
Okay?